Have you ever looked up at a snowfall and thought about how much history is hidden in it? Not the kind of history we read in books, but the kind that falls quietly, that settles and melts, that drifts through time unnoticed. Every snowflake has a story, and so do the people who have spent their lives trying to capture them, study them, preserve them, and understand them. This isn't just a story about winter or weather or even science. It's a story about curiosity, about people who looked at something everyone else ignored and said, wait, there's something here worth keeping. Our story begins in the late 1800s in Jericho, Vermont, with a boy named Wilson Alwyn Bentley. He lived on a small dairy farm, and like most farm kids, he knew weather intimately. It controlled his family's livelihood. But Wilson had a fascination that made him different: snowflakes. He once said, "Under the microscope, I found that snowflakes were miracles of beauty. It seemed a shame that this beauty should not be seen and appreciated by others." So he made it his life's mission to photograph them. He built a contraption in his barn, a bellows camera rigged to a microscope, and began catching snowflakes on black velvet before they melted. Imagine him out there, a lantern in the darkness, breath freezing in the air, hutched over a glass slide while the rest of Vermont slept. Wilson Bentley spent over 40 years doing this, photographing, cataloging, and describing more than 5,000 snow crystals. But here's the heartbreaking part. The scientific community didn't take him seriously. He was dismissed as a hobbyist, a farmer playing scientist. His work was too artistic, too romantic, and too rural. It wasn't until after his death that the world realized the magnitude of what he'd done. That his photographs weren't just beautiful, they were scientifically invaluable. Bentley gave us proof of what we know, that no two are exactly alike, a fact that's both poetic and scientifically complex. And there's a lesson there. Sometimes the work that changes the world starts with someone the world doesn't take seriously. Before Bentley's camera, there was another way of recording snowflakes: by hand. Enter Cecilia Louisa Glacier. Born in 1812, an English artist and illustrator who worked alongside her husband and meteorologist, James Glacier. While he studied weather and atmospheric pressure, Cecilia was sketching the microscopic beauty of snow crystals. Over 150 individual designs between 1855 and 1857. Her drawings are astonishingly precise. Each snowflake meticulously inked, labeled, and shaded, made from direct observation through her husband's microscope. But, like so many women of her time, her name was largely omitted from the published works. The plates were credited to Mr. Glacier, even though Cecilia was the artist, the eye, and often the steady hand behind the microscope. It's only in recent decades that historians have rediscovered her contributions. The Fitzwilliam Museum and the Royal Meteorological Society now archive her drawings, works that were crucial to how 19th century scientists classified snow crystals. Cecilia's snowflakes bridged the gap between art and data. Her drawings help scientists recognize symmetry, patterns, long before photography could capture them. She didn't just draw snowflakes, she translated them. And doesn't that feel like the story of so many women in science, translating what others can't yet see with patience and quiet brilliance, often without credit? Across the ocean, another visionary was peering into a microscope. Yukichiro Nakaya, born in 1900 in Japan, he grew up near the Sea of Japan, where heavy snows were a part of life. He became fascinated with snow crystals, not just as natural wonders, but as physical puzzles. Nakaya achieved something that had never been done before. He created the world's first artificial snowflake. He built a cold chamber and used a single strand of rabbit hair as the starting point, a nucleus around which the ice could form. Slowly, under precise humidity and temperature conditions, a tiny hexagonal plate appeared, then branched, then bloomed into a perfect snow crystal. He called it a letter sent from heaven and wrote about his experiments in a book that combined hard science with gentle poetry. His first snowflakes proved that environment shapes design. By changing temperature or moisture, he could produce different types of snow crystals: stellar dendrites, needles, hollow columns. His work was so detailed that NASA later used his data to understand how ice crystals form in clouds. But Nakaya wasn't just a physicist, he was also a painter, a writer, a teacher. He brought art into science, the way Cecilia brought science into art. I like to think that if Bentley, Glacier, and Nakaya could sit at a table together, they'd talk less about snow and more about beauty. about how the act of seeing can be revolutionary. Now, let's talk about a few women whose work you've probably never heard of, and yet without them, we might not have modern snowflake classification systems at all. In the early 1900s, as meteorology became more formalized, researchers began creating enormous catalogs of ice crystal shapes. Many of these projects relied on assistants, women, who were paid little, credited less, and often did the most intricate parts of the work. One of these women was Mary E. Bradley, who worked for the U.S. Geological Survey in the late 1800s and early 1900s. She helped document crystal formations from polar expeditions, making thousands of detailed pen and ink drawings. Then there was Helen Freeman, a lab assistant in Scandinavia who observed snow crystal changes during storms, recording how temperature shifts changed crystal type. Her notebooks, though unpublished, became part of the early European snow atlases. And Rachel Whittaker, a British crystallographer, was known for her delicate tracing techniques, which helped early 20th century scientists identify transition stages between crystal forms, something no one had noticed before. Their work formed the quiet backbone of snow science. They built the visual and structural languages that modern researchers still rely on. When you look at a snowflake diagram labeled stellar dendrite or sectored plate, that lineage traces back to those women, hunched over, microscopes in unheated labs, sketching before the samples melted. Fast forward to Iceland, 1979. The air is bright, the snow is dense, the nights endless. Tryggvi Emilsson, a chemist with a fascination for polymers, was trying to answer a question that had haunted snow scientists for a century. Could you preserve a real snowflake? The challenge wasn't the freezing, it was time. A snowflake's crystal lattice begins collapsing the instant it's touched by warmth or air moisture. Most preservation methods either destroy the pattern or create a frozen copy. Not the real thing. Emilsson experimented with tiny polymers, cyanoacrylates similar to superglue, formvar, and polyvinyl acetal. What he discovered was remarkable. Under specific freezing conditions, some polymers could react chemically with the outer molecular layer of the snow crystal, bonding to it and solidifying its shape before it melted. It was chemistry's version of catching a ghost mid-breath. His technique, published in obscure Icelandic journals, allowed snow crystals to retain their original structure, not a mold. That's an important distinction. What remained wasn't an imitation, it was the actual geometry locked in time. For artists like myself, Emilsson's discovery became our foundation. When I preserve a snowflake today, I'm carrying forward his work, expanding it from the laboratory to the studio, from science to story. Around the same time, other scientists were exploring something that sounds almost mythic: controlling snow. During the Cold War, both the US and Soviet Union funded weather modification experiments. They seeded clouds with silver iodide and dry ice, trying to induce or prevent snowfall. Some projects succeeded on paper, but most didn't replicate nature's precision. They could trigger ice formation, yes, but the intricate branching that makes a snowflake, nature, it turns out, guards her geometry fiercely. And while those experiments faded into secrecy, they remind us of something deeply human: our endless desire to control what's fleeting. Bentley tried to capture it, Nakaya tried to grow it, Emilsson tried to preserve it, the Cold War tried to manipulate it, and here we are, still marveling at the same crystals falling from the same clouds. If science tells us what snowflakes are, art tells us what they mean. Bentley's own book, Snow Crystals, wasn't just data, it was poetry. His captions read like love letters to winter. Later, physicist Kenneth LeBret, one of the foremost snowflake researchers of our time, continued that legacy, blending science and art in his books, The Snowflake, Winter's Secret Beauty, and Ken LeBret's Field Guide to Snowflakes. He even consulted on Disney's Frozen to make sure the movie's snow behaved accurately. And if we step outside science for a moment, there were writers like Nancy Hudson, who described snow as a form of forgetting, or poets like Mary Oliver, who wrote that the snow began here this morning and all day continued, its white rhetoric everywhere. There's quite a lineage there, from microscope to metaphor, connecting those who study snow crystals with those who dream through them. There's something romantic, almost rebellious about these people. Bentley's patience, Cecilia's precision, Nakaya's poetry, Emilsson's chemistry. They remind us that wonder itself can be a discipline. Each one found a way to do the impossible, to make time hold still long enough to see what it's made of. That's what I try to do. When I collect snowflakes in freezing air, I'm not just preserving shapes, I'm preserving moments. Tiny collaborations between water and wind, between chance and structure. Sometimes I wonder if snowflakes are the universe's handwriting and we're just the archivists, lucky enough to keep a few pages. So why does this history matter? Because every one of these stories, from the farmer to the physicist, to the forgotten women in the cold laboratories, shows us what happens when curiosity refuses to give up. They looked at snowflakes, something we all see but rarely notice, and saw worlds within worlds. They proved that beauty and science aren't opposites, they're partners. And I think that's something we need to remember, not just in science, but in life. You don't need a microscope or a lab to see miracles. You just need to look closer. So the next time it snows, pause for a moment, hold your glove out, and let a snowflake land. And instead of brushing it away, watch it. You're looking at the same geometry that captivated Bentley, that Cecilia drew by candlelight, that Nakaya grew from a rabbit hair, that Emilsson caught before it vanished. A design that's existed for millennia and might never exist again. Snowflakes don't just melt. They tell us who we are when we're paying attention.